Hi everyone, welcome back. So today we'll be continuing with previous year question discussions of electrochemistry. So the first question is on the screen. The cell voltage of a Daniell cell. So ഒരു തവണ ഈ ഡാനിയൽ സെല്ലിന്റെ റെപ്രസെന്റേഷൻ അങ്ങനെ തന്നെ ചോദിച്ചിട്ടുണ്ട് കറക്റ്റ് റെപ്രസെന്റേഷൻ എന്താണുള്ളത് സോ അതൊന്ന് നോട്ട് ചെയ്യുക on the left hand side we have the oxidation half cell and then on the right hand side we have the reduction half cell. Okay, if reduction potentials of Cu2 plus bar Cu is 0.34 volt, the reduction potential of zinc is, now this is a very easy and direct question, E naught of any cell is equal to E naught of the cathode minus E naught of the anode, that's all. Okay, E naught of the cell is given at 1.07 volt, which is equal to E naught of the cathode is also given. Whenever a cell is represented, the left half, this is a salt bridge. Double stroke represent the salt bridge. So a salt bridge in the left hand side the oxidation half cell, right hand side the reduction half cell. So copper is getting reduced and its reduction potential is given as 0.34 volt minus anode on zinc. So you can rearrange this. And this is equal to 0.34 minus 1.07. Negative value variable, so definitely it's not A, it's not C. Subtract it, you will be getting minus 0.73 volt. So it's option D. Minus 0.73 volt. Option D. Yes. Moving on. Next question. Again, same equation application and the structure on the they have given three reactions. Okay, A, B, and C. The overall reaction for the cells in the direction of spontaneous change would be. So now let's discuss about this first. Spontaneous change. Spontaneous change parnal, two things. One, delta G should be negative. Delta G negative aya matramana namukku or electrochemical process spontaneous aanennu parayan pattullu. So that is the first case. Now we know that delta G for a cell it is equal to minus NFE. Appo delta G negative aganamengil, so this negative sign should be retained here, meaning E cell, this should be positive. Alle, that is E cell is equal to, it is E cathode minus E anode in the previous question, right? So this as a whole should be positive. Ingil matramana this spontaneous agullu. Now let's check the options. And the options in the combination that they have taken is A, B, A, C. A, B, A, C, A, B, A, C. So that is A, B, you have minus 0.877 volt and 1.66 volt. In this R cathode, R anode. Now see, always remember, the potential. Is it the reduction potential or the oxidation potential? So here, what you have is ion is in +2 oxidation state. It's getting reduced to 0 state. So the reduction potential. +3 is being converted to 0. Again, this is reduction potential. Ivide Ag plus is becoming Ag0. So this is also reduction potential. Because oxidation potential you have to convert it to reduction potential. That is oxidation potential X units like X volts reduction potential it is minus X volts. That's all. Conversion just in case upcoming examinations in conversion note. Okay, so now the first set that they have taken is A and B. A and B we have to choose which is the cathode and which is the anode. The more positive value of the reduction potential, better cathode it is. Okay, for example, if you have PQR, mono cells let's say this is 1 volt, let's say this is minus 1 volt, 0 volt and plus 1 volt. This is just an illustration. These are all reduction potentials. So this scale PQR in increasing order place ചെയ്തിരിക്കുന്നത്. This is the best cathode. Okay, more the positive value of the reduction potential, better cathode it is. Okay, so even P would be the best anode material and R would be the best cathode material. Adhe principle nammal ivide use cheyana. You're taking A and B. If you take A and B, the more positive value is for B, meaning that would be the cathode. Okay, that would be the cathode. So if you take first set A, B, we said that B is the cathode and A is the anode. Anode whatever the type of the process is, whether it is electrolytic or electrochemical, ഏതാണെങ്കിലും ആനോഡിൽ എപ്പോഴും ഓക്സിഡേഷൻ ആണ് നടക്കുക. സോ അയോൺ ഇസ് ഗെറ്റിംഗ് ഓക്സിഡൈസ്ഡ് അല്ലെ, ഇതാണ് നമ്മുടെ ആനോഡ് മെറ്റീരിയൽ എന്ന് പറഞ്ഞു. സോ അയോൺ ഇസ് ഗെറ്റിംഗ് ഓക്സിഡൈസ്ഡ്. സോ ദാറ്റ് ഇസ് ദ ഫസ്റ്റ് സ്റ്റേറ്റ്മെന്റ്. എയും ബിയും നമ്മൾ എടുക്കുമ്പോൾ B is the cathode and A is the anode. Now we have to check whether it is spontaneous. അതാണ് നമുക്ക് അറിയേണ്ടത്. സ്പോണ്ടേനിയസ് ആണോ എന്ന് അറിയണമെങ്കിൽ നമ്മൾ എന്താ ചെയ്യുക? യു ഡു E cathode minus E anode. അതെന്താ? E cathode is 1.66 minus E anode is minus 0.877. So definitely this is a positive value and hence E cell positive ആയതുകൊണ്ട് this is spontaneous. ഈ ഒരു spontaneous change ൽ anodic material എന്താണോ that will get oxidized. So A, B spontaneous ആകുമ്പോൾ who is getting oxidized? Ion is getting oxidized. Option A le ion reduced ആണ്, so this is wrong. Okay, option B lum ion is getting reduced, so this is wrong. C lum D lum ion is getting oxidized, so the രണ്ടിൽ ഏതെങ്കിലും ആവാം. Now let's compare A and C. A and C. A and C le the best cathodic material is that of silver. Why silver? കാരണം ഇവിടെ -0.77 വോൾട്ട് ആണ്, -0.877 volt ആണ്, ഇവിടെ 0.07 volt ആണ്. So this is more to the positive side and hence silver electrode is a good cathode compared to ion. So this would be the cathode and this would be the anode, and definitely E cathode minus E anode cheyumbo you will be getting positive value. And who is getting oxidized? Ion is getting oxidized. A, C യും compare ചെയ്യുമ്പോഴും ion is getting oxidized, പക്ഷെ ഇവിടെ ion is getting reduced എന്നാണ് എഴുതിയിരിക്കുന്നത്. Right? So it is option D, which is correct. Yeah. കുറച്ച് lengthy ആണെന്ന് തോന്നും, but then it is very easy. Now again, this is a question from Nernst equation. The correct delta G for the cell reaction involving, again നോക്കൂ, Daniel cell ആണ് represent ചെയ്തിരിക്കുന്നത്. So overall reaction നമ്മൾ എങ്ങനെ എഴുതാം? ഇവിടെ തന്നെ നമുക്ക് എഴുതാം. You write the overall reaction. 2 electrons LHS ഉണ്ട്, RHS ഉണ്ട് അല്ലേ? So നമുക്ക് എന്താ കിട്ടുന്നത്? Zinc in solid state, which is the electrode, plus Cu2 plus aqueous will give you zinc 2 plus aqueous plus Cu solid. This is the overall reaction. And we know different forms of Nernst equation. So the one of the form in the choichal delta G at any condition is equal to delta G naught plus RT by RT by NF വരുന്നത് when you take E. And നമുക്ക് പറയാം ln oxidized concentration ആണ് വരിക, oxidized species by reduced species. This is equation. അപ്പൊ ഇവിടെ what you have, ആരാണ് oxidized ആകുന്നത്? Zinc 2 plus ആണ് oxidized ആകുന്നത്. Delta G ആണ് ചോദ്യം. So that is equal to delta G naught plus RT ln zinc 2 plus by ആരാ reduce ആവുന്നത്? Copper ആണ് reduce ആകുന്നത്. So it is copper 2 plus here. That's all. Always note, we never take the concentration of solid species. അത് 1 ആയിട്ടാണ് എടുക്കുന്നത്. That's why aqueous മാത്രമാണ് എടുക്കുന്നുള്ളൂ. Okay, whenever you have an equilibrium reaction A plus B giving C plus D, within the reaction coefficient or equilibrium constant, always the way you write it is like this: concentration of C into concentration of B divided by concentration of A into concentration of B. അതേപോലെ നമ്മൾ ഈ reaction എഴുതുകയാണെങ്കിൽ what you can write is the constant reaction coefficient is actually zinc 2 plus into concentration of copper, which is a solid, divided by Cu2 plus into concentration of zinc, which is also a solid. Solids ne nammal 1 ആയിട്ടാണ് എടുക്കാറ്. So you need not consider them. That's it. So which is the correct expression? Delta G is equal to delta G naught plus. Minus minus. It's not A, it's not C. RT ln, instead of concentration, they have used the term activity. That's all right. Activity of zinc 2 plus by copper solid. That's wrong. So it's not option B also. At the denominator, you should have activity of copper 2 plus. So it's option D. Direct. Okay. E equation, when you substitute delta G is equal to minus NFE and delta G is equal to minus NFE naught. E and equations if it substitute cheyumbo, you get another expression. That is minus NFE is equal to minus NFE naught plus RT ln. Let's go with the Daniel cell. Zinc 2 plus by Cu 2 plus. Now you divide the whole equation by minus NF. You divide the whole equation by minus NF. So it will give you E naught minus RT by NF ln zinc 2 plus by Cu2 plus. Okay. Different forms of Nernst equation. Good. Fourth question. Now, this is a theory-based question in which they have asked, in Kohlrausch's law, lambda m is equal to lambda m naught minus k, which is the Kohlrausch's constant, into root of c, where lambda m naught and k depends on. So there are four options given. It depends on the stoichiometry. It depends on the specific identity. It is independent of specific identity. And option D, A യും B യും ഉണ്ടെന്നുള്ളതാണ്. That is specific identity name, അതുപോലെ തന്നെ stoichiometry name depend ചെയ്യുന്നുള്ളതാണ്. So the correct answer is option D. Okay, so you have to know that with each electrolyte, the Kohlrausch's constant will change. Okay, it is different for HCl and is entirely different for H2SO4 and it is pretty much different from HNO3. So depending upon the electrolyte which is chosen, the Kohlrausch's constant will change and obviously lambda m naught will also change. Okay, because the conductance, limiting molar conductance for different electrolytes would definitely be different. So it does depend upon the identity and the stoichiometry. Okay, yes, so it's option B, theory-based question. Anna. Now, last question, this is important. Thermodynamics side related to your question. The temperature dependence of an electrochemical cell potential is. Okay, so for that, നമ്മൾ ആദ്യം അറിയേണ്ടത് ഒരു റിലേഷൻ ആണ്. നമ്മൾ thermodynamics നിന്ന് കടമെടുക്കുന്ന ഒരു ഇക്വേഷൻ ആണ്. Actually, this is a relation which is delta G is equal to minus S dt plus V dP. This is a relation. Okay, minus S dt plus VDP. So what they want here is the temperature dependence. In which temperature vary cheyyumbol endana sambhavikka ennulladaanu avarku ariyendathu. So for that you will take a assumption that the pressure is constant. Pressure constant parnal dP is 0. If dP is 0, this equation, if it is 1, even 0 aipo, right? So what you will be getting is delta G is equal to minus S dt. Now what they need the temperature dependence potential actually. But the delta G, but before that, just rearrange this. And then you can write it like this, like delta G by dt. This is equal to minus S, right? Okay, now none of the options are matching over here. Why? Because average temperature dependence electrochemical cell potential. We know the relation delta G. E relate it is minus NFE by dt is equal to minus S. So now you have E electrochemical potential. Engine temperature change change. You bring this minus NF to the right. So this is temperature dependence on electrochemical cell potential. On electrochemical cell potential is equal to minus S by minus NF. Minus minus get it home. So you have S by NF. Yes, it's X by NF. Okay. So since we are measuring a change, S by NF, which is E. Okay, so if you measure a change, like the E by dt is equal to minus delta S. So if you're measuring a change, this would become delta E, change in the potential, because temperature മാറുമ്പോൾ എങ്ങനെയാണ് EMF മാറുക എന്നുള്ളതാണ് അവർക്ക് അറിയേണ്ടത്. So the change in the potential with changes in temperature is equal to delta S by NF. Yeah, so that would be option C. Option C. Yes, so that's all for today. Thank you. See you.